fondly call the MIT of the South. So come down and visit us all when you get a chance. I noticed when this MIT A+B conference was first advertised that it did talk a lot about mobilizing technologies. And I thought, oh, I need to be there. I want to contribute to that discussion because with my co-author, Snehal Kale here, also from Georgia Tech, a PhD student, we've been working on lessons about mobilizing, especially residential markets, but not entirely, also industrial and transportation, electric vehicles, et cetera. Mostly within the US, and spending a lot of time on the state of Georgia. You know, it's a home state for my institute, so we have a good amount of funding to look more closely at what's happening close to home. We have this interesting conundrum where the state of Georgia is the hotbed of so much technology and innovation. It's now become a hotbed of manufacturing. We have many new plants going in for solar and for heat pumps, for hydrogen-fueled trucks, and yet our percentage of these technologies being adopted by our own Georgia state citizens is very low relative to that of the rest of the nation, and certainly low compared to many European countries. So it's that conundrum that sort of got me interested in talking with you all today. So we're going to be talking about electric cars, rooftop solar. Let's see, is it on? There's only the one thing that's. Oh, click and go to the. Yeah. You want me to screen, not this?
No, I think no as well. No.
No. There we go.
Yeah.
Okay, got it. All right. So outline of the talk, just want to introduce that we'll be discussing the adoption of key climate friendly electric technologies. How can the pace of change of their adoption be accelerated, and are there policies that we need to design explicitly to tackle the nature of the resistance that's inhibiting their diffusion? So we've discovered in the literature green signaling and fuel cost savings, sustainable lifestyles, lots of correlates, but do they apply equally to all these technologies? Is the sustainable lifestyle what's driving every type of technology? So we've got a lot of research questions revolved around the mobilization conundrum that I mentioned. I'm building on a 5-year project called Drawdown Georgia, which is an effort to look at the state of Georgia to see how we can get it to a net neutrality position by half century, and the Paris Accord goals in the meantime. And to do that, we identified 20 technologies that were considered high potential for reducing emissions in the state, and they span all of the sectors you might imagine, transportation and electricity being the biggest, buildings, commercial and industrial, and materials, but also agriculture and forestry as carbon sinks. So we're looking at it all. We've been helping the state of Georgia to develop its first climate action plan, and these 20 solutions that I didn't bother naming, but you could imagine what they are, were key to that action plan. The three I'm going to talk with you today about, I call the tech triad, and that is its heat pumps, rooftop solar, and electric vehicles. And what's interesting, the reason we drew this circle of dots by different technologies and sectors is that each combination of solution works differently in tandem. And so you have to talk about how electric vehicles are great, particularly if you have renewable electricity, right? And heat pumps are wonderful. They're not all that important if you had all renewable electricity, though. So lots of complications about this package as a whole, but we're in right now a status where all three of them together as a package are what we need to drive toward. Their pace of adoption is slow, and we are going to be looking at why that might be the case. Oh, we are building on a theoretical framework of factors that influence technology adoption generically, a couple of theories that are well honed and accepted in the literature about technology change in general, and some of the social psychological theories of how individuals make decisions. They're called the theory of innovation diffusion and the theory of planned action. So in the theory of innovation diffusion, you mostly are looking at experience and attitudes and social influence. And planned action is a little bit broader in scope and also includes more of the context within which these decisions are made. We've done a review of the literature organized along the lines of this framework. That is, what are the internal motivators and barriers? That is the socio-psychological by internals, what we mean here, experience and familiarity. Who has experience? Who's ever seen a solar panel in operation? Surprising that many don't have any anywhere near their neighborhood in rural Georgia. You have to go to the city to see some of these technologies. You got to be in an urban place to see charging. So there's a whole familiarity dimension that we built into our research. Attitudes and social norms. What do others who are important to you think you should do? But we've expanded the theory of planned action and innovation diffusion to also focus on external motivators and barriers, in particular the barriers that infrastructure support. So if you don't have, I mean, all in my prior years, many years of this type of research, it was often that you couldn't get a supply chain near you. You couldn't find the technology in the stores you go to shop in. Well, now it's also that you can't find a way to charge them. You don't have the fiber optic Wi-Fi to use them. So there are all sorts of infrastructure limitations that, the Biden administration has smartly developed a whole, actually, Department of Energy infrastructure development organization to tackle this, recognizing this. Then there's the policy ecosystem. It's not just where can you get it, but it's where can you get the subsidies or support or the messaging to want to go purchase one. So we have to look at the policy ecosystem. And then all of that is operating within the context of the socio-demographics of the decision maker and their network of contacts. So that's the world in which we need to talk about how to mobilize change. So the literature is extensive, but yes, gaps do exist. And so I won't spend much time on this, but this was a search of the literature Web of Science in 2017 to 2024 that Snehal did. And you can see who's doing the work in what countries of the world and who is collaborating and on what topics are they examining these issues. And you can see the survey research is pretty well situated in that top panel on clusters of climate smart technologies. Those kinds of terms bring a lot of social science survey research into the publications, because that's what you need to understand how decisions are being made. And that's what we use. So our goal first is to address the gap of in the notion of interest. We talk about people who are interested in purchasing one of these three, the tech triad, one of those technologies. But the notion of interest is actually very multidimensional. It's wrapped up in, do you know anything about it? And who do you get your information from? And is there a policy that's made you particularly interested because you could see there's an economic payback? No, so the notion of interest as a multidimensional scale is something we've been developing. It also is correlated with this observational familiarity. So in a state or across the US, there are whole regions of the country that have never seen some of these gadgets. We all have. Of course, we're surrounded by them at universities, but not so much in the mainstream. So, and then the external infrastructure issues, as I mentioned. One thing that the research we're doing now is has organized to do is to consider the sociodemographic dimension, the latent issues, that is the widely impacted, complicated issues that have to do with your wealth, your race, your gender, all variety, your family size, where you live, urban, you know. So all of that, it gets very difficult to examine because there's so many dimensions to it. So we'll talk about how we've tackled that. So this is our variable, what's called a multidimensional measure of interest. And we combine the idea of whether there's any inkling of interest, any familiarity, any knowledge, any understanding of the policies, and are you driven by those policies? Are you interested and knowledgeable? Have you adopted, but you really don't know what you've done? Maybe you bought the house and it had it in it, and you're just using it. Or are you a full, you adopted and you're knowledgeable, and then you get a score of 7 on an 8-point scale. So our hypotheses are that drivers and barriers to these 3 different technologies are quite distinct. You can't just draw conclusions that apply to all climate smart electricity solutions. There are latent factors that influence technology adoption, the predisposition to adopt. And one of those we haven't talked about too much is sustainable lifestyle, which the literature has suggested is a very powerful predictor of what a person will do, is what their lifestyle is like. And then the multidimensional nature of the dependent variable, which we think our hypothesis is that multidimensional indicator of interest is going to be a more powerful predictor of adoption. So we did a survey. We had about 1,800 participants from across the state of Georgia, from the 123 of its 159 counties. And we only included adults, and we got a pretty good distribution across key characteristics. We had to go back and fill in a little. Too many older people answered, too many white people relative to the population. So we did a little bit of enhancement with the Dynata data company that did this for us. A third of the participants were asked questions about solar, a third about heat pumps, and a third about electric vehicles, but they were all asked a very large battery of tests about everything. And they were asked if they'd already adopted any of these, and if they had, they were asked different questions than if they hadn't. So we talk about 3 groups of our participants by technology, and we also divide them into, are they adopters of the technology? Are they interested non-adopters? Or are they disinterested non-adopters? By the way, in this drawing in the middle, I had to ask Snehal, what is that person carrying? They're carrying an electric charge to their car. They just haven't put it in there yet. They're just thinking about, right? Maybe they have a house with a charging station. They're maybe going to put it to good use. So we do our usual assessment of how intercorrelated our different predictor variables are. We take all of that into account in our multivariate analysis. I love this diagram. I like to show it because it's just such a beautiful portrait of statistics. So what we can focus on are the three diagonal matrices. Right, so we're looking at the colorful ones right down the middle there. And we do have a distribution shown here. Here.
Next.
And here. Oh, you've done that. All right. Let's see. And tested this. Oh, here we go. All right. So in this distribution, you can see that we're looking at the willingness to pay. How much of a return on investment would you require to be willing to purchase this technology? And on this box, we're looking at electric vehicles, and you can see that those who those who are interested in adopting have a willingness, are willing to pay more for technology than those who don't have an interest in adoption. So that's the scale and the way that was our expected relationship, that interest would follow, it make you more willing to pay more as an upfront cost. So that's a finding that you see across all of these matrices. And also you can see that in the upper right-hand corner here, here and here, the negative correlation, again, you're interested and you're willing to pay more. It's a sort of repeated pattern there. And the three bullets here give you a little bit more information about our findings just from descriptive analysis. Cutting energy bills is a stronger motivator of adopting heat pumps than adopting rooftop solar. So people in the rooftop solar market are not always driven, or not driven as much as those who are out to buy a new heat pump, an advanced heating and cooling system. I don't think that's surprising. We find that the solar market is significantly impacted by a desire to show off your commitment to sustainability. I call it the bling effect. High upfront costs are a stronger barrier to rooftop solar than to heat pumps. High upfront costs are a stronger barrier to solar than heat pumps. Rooftop solar is arguably often more expensive, so that's possibly one of the reasons. But uncertainties about costs and benefits are really important for electric vehicle in terms of the purchase of an electric vehicle. Many people don't know how they operate, what they cost, how much the gasoline costs relative to the electricity, how they recharge, where would they go, how would they get a charging station, etc. So very interesting and not too surprising findings, understandable findings. This latent dimension, we know we have so many variables, we've got to reduce them to dimensions, and we do that through factor analysis. We come up with affluence, sustainable lifestyle, climate attitude. So are you concerned about tackling the climate crisis? And demographics, age and household size. Those are the key variables for this highly important technology triad. So we look at reasons for adoption for those who have adopted, and for heat pumps, lower bills. I had mentioned that before. This is the technology that's often seen as a way to handle the cost of the high energy burdens that many people face. Policy motivator is a standout for solar adopters. Remember their upfront cost is such a barrier. So they're looking for those subsidies. Resale value, really important for electric vehicles. You change cars often, more often than you change your solar system and your HVAC system. So that's, again, not too surprising. And there's a lot of uncertainty throughout the US and around the world about what you'll be able to get back when you go into the resale market mode. So we do our usual kind of multivariate regression analysis and are able to fairly successfully predict that. So we're looking at interest as a, remember our hypotheses, that if we have this multidimensional variable called interest, we'll be able to understand the behavior of individuals better. We've discovered that interest is, in fact, highly correlated with where you live. And I just want to quickly turn to this map. Here's Georgia, 159 counties. We have a solutions tracker up and running, and I've got it hot linked on this website. I don't know if these PowerPoints are going to be posted anywhere, but you'll be able to go to the tracker, and you'll see that observational familiarity is urban constrained when it comes to EVs. People in the rural Georgia counties don't have any in their neighborhood, right? Rooftop solar is wealth constrained. You find them in wealthy neighborhoods. So the observational capacity is much greater there. You'll know many people who have them, and you can address your uncertainties and questions about them. Heat pumps, they span the entire state of Georgia and don't have either the observational familiarity or the wealth, the urban or the wealth constraint. So my last 3 slides, do I still have time?
Yep, we're in time.
All right. Deal with what are the policy implications. And I'm going to turn to 3 cities that have done well, each with a specific technology. So LA, not surprisingly, is our pick for the best policies to promote electric vehicles. And the policies they choose fit this portfolio of barriers and drivers that we've identified in our survey research. So they have streamlined the permitting process. They have EV-ready building codes, charging and public chargers everywhere. But they most of all have a lot of money that you can take advantage of when you buy your EV. $1,500 from the state, $1,500 from your utility, $2,000 from the city of LA, and pretty soon you see that they're more than compensating for the incremental cost of an electric vehicle. So they're getting at that cost factor. Honolulu for rooftop solar is our pick for a leader. Of course, they have 20% penetration compared to, yes, 0.2% penetration in the state of Georgia. What have they done to do that? Well, cash is again another important policy instrument. They also have net metering, where they'll buy back your excess electricity at the retail rate, performance-based system for quick connection. That's always an issue. It takes forever to get your solar system approved. I've done it in Atlanta. I've done it at Cape Cod. So much easier at Cape Cod. So difficult in Atlanta. And that's just bureaucracy. So lots of ways that Honolulu has created that 20% winning level of penetration. And then finally, for energy efficiency, here, remember that it wasn't so much that it was going to cost a lot. I didn't mention this, but one of the barriers is you already may have gas heat. And if you've already gone with natural gas in your home HVAC system, it's difficult to rip it out and go all electric. So policy often, when it is faced with such difficult intransigencies, they go with regulation. No more hookups for natural gas in the city of New York and increasingly in many other cities around the world, because that's the only way to prevent the difficult trade-off and continuing in the future when people continue to, if people were to continue to go with gas and then be asked to turn to an electric heat pump system. Of course, some subsidies and commitment. No fossil fuel hookups, 20% reduction in energy consumption for the city's buildings. I wanted to show you again my continuous complaining about Georgia. We are surrounded by the great states of Tennessee, North Carolina, South Carolina, Florida, and Alabama. We have the hub of heat pump manufacturing with Rheem in the city of Atlanta, its U.S. headquarters, making all the internal equipment for the mini split heat pumps, right? And here we are at 27%, outdone by every one of our neighbors. So I can't say that we've come up with an exact menu for success in policy, but we've, I think, arrived at some really good conclusions. We need savings for heat pumps, important resale value for cars, supporting policies, especially funding for rooftop solar. Got to customize those policies. There's no one size fits all across this triad. Environmental messaging is really good. People who have that sustainable lifestyle over and over again, we see are the ones you should try to reach and make sure you have 100% penetration by them. And tailored economic solutions are really required, particularly for low-income households, the very difficult to reach part of the population. And that's it.
All right. Thank you so much for this great insight into your research. The two of us, we have to talk because we essentially did something very similar, essentially for rooftop PV and for electric vehicles in Germany using AI, so data-driven approach. And we found actually similar results. So, and also the what we see for PV in Germany is actually that over time, to the beginning, it was mostly driven, in fact, by the irrigation, which differs from the northern of Germany. And now over time, that's actually switched to rooftop space. So individual houses and the main driver right now. Yeah, can continue. Any questions, Bonnie? Yeah. Sorry. So state of Georgia have a program. Where you like someone which is really great for see if they do or don't have anything out there.
Yeah, we do. With the last Public Utility Commission hearing, which I testified in, we were able to avoid payback at avoided cost. Avoided cost is about 3 cents per kilowatt hour, but we didn't get it at retail, which is about 18 cents. They gave us 6.5 cents per kilowatt hour when they buy back what you don't use. And that's not very motivating. So, but it was better than their going in proposition. So, but not enough really to move the market. That was a problem. Yes, that's a good, thank you. Great question.
So characteristics so sewer all that all
No, that did not come up. Did we have any evidence of any of that in the hall? I don't think so. Partly because, I mean, perhaps if we go enough into the future, we'll see that maybe with discontent over the particular EV that they purchased, and maybe they go back and they want to do a hybrid or, you know, something different. But we did not see any of that. You're stuck with it. You know, this is very sticky technology. You move your HVAC system over and you're, you know, hard to go back. Same with solar.